Dear colleagues, hi. My second report at the conference is devoted to Matrix Aggregate Calculator, MAC technology as a tool for express economic systems evaluations. When we analyze some system property, we may represent it like a hierarchy of sub-properties, level 1, which their own assets of some sub-properties, level 2, level 3, and so on. It's a manifestation of fractal principle for systems. Every property has its own referent indicators that should be measured. For example, if we evaluate economic resilience, we may establish two-level hierarchy with one-level sub-properties as blocks: profitability, turnover, cost of capital, and labor efficiency. Every sub-property may be characterized by 3-4 parameters in a level 2, not more, because additional parameters in schema or will be invisible because of little weight. Let us describe our MAC technology step by step. On step 1, we should establish a schema of main property, like an hierarchy, and to choose all referent indicators for sub-properties to establish measurement procedure for them. We also need to establish main indicator and range for it. For example, for resilience, it might be resilience indicator, RI, in range from 0.1 to 0.9. On step 2, we need to find out preference system for blocks in scope of main property and for parameters in scope of sub-properties. When we formulate preference system, we use links as strong preference, weak preference, and indifference. It's an area of expert responsibility. When all of preference systems are completed, we set weights P for every block and for every parameter in schema using so-called Fishburne rule. On step 3, we interpret every parameter as a linguistic variable. This implies that there is big data asset for comparison and statistic homogeneity of data. Here you see classification table for 12 parameters in worldwide mechanical engineering branch. Similar tables we have got for oil and gas, energy, and other branch of industry. Also, we need to choose so-called node points to establish a dimension of integral property indicator. For example, if we expect resilience indicator in a range from 0.1 to 0.9, node point array Y is 0.1, 0.3, 0.5, 0.7, 0.9. It's a kind of calibration. On step number 4, we form matrix, where rows are parameters and columns are qualitative levels of parameters according to their classification. On a cross of rows and columns, we have membership function values mu in range from 0 to 1. If there is crisp granulation, mu is 0 or 1 exactly. Sum of all mu's within one row is 1. Finally, on step 5, we calculate Ri using formula on slide. No problem to make linguistic classification as it's shown on slide. Here you see example of MAC with two-level hierarchy and 5 parameters which are given qualitatively. Block 1 is profitability, block 2 is turnover. We use crisp granulation here. Let me call 5 key spheres where MAC is applied in Russia. Firstly, Sphere 1 is comprehensive financial analysis of organizations. First applications MAC in the sphere is dated by 2003. There was at about 300 enterprises, 20 quarters and 16 parameters. Sphere 2 is estimation of the fair value of real estate objects. It supposes construction of a set of non-dominated Pareto alternatives in quality price coordinates, constructions of an efficient frontier of the portfolio set. Sphere 3 is assessment of the economic efficiency of regions. First applications are dated by 2003. 89 regions of Russia was estimated using MEC. Sphere 4 is risk assessment for coal industry facilities. Now it works like as a Russian government standard. You may see it using a hyperlink presented on the slide. And the last Sphere 5 is assessment of the economic resilience of international industrial companies. You may see our previous report to make sure. So we celebrate 22 years of MAC this year. So that's it. Thank you so much for your attention. I'm ready for your question.